Shri Rajalakshmi Prakashan published. A textbook on fundamentals of agronomy 1. Authors Dr. D. N. Jagtap, Dr. P. B. Pawar, Dr. U. V. Mahadkar. Chapter 9th. Nutrient use efficiency, meaning and factors affecting nutrient use efficiency. Nutrient use efficiency. Nutrient use efficiency, NUE, may be defined as yield per unit input. In agriculture, this is usually related to the input of fertilizer, whereas in scientific literature the NUE is often expressed as fresh weight or product yield per content of nutrient. Factors affecting manures and fertilizers use or nutrient use efficiency. Major factors influencing the selection, quantity, time and method of application of manures and fertilizers are soil factors, crop factors, agronomic factors and other factors. Soil factors. The most important factors are soil physical condition, texture, soil fertility and soil reaction. Poor physical condition of the soil leads to poor plant growth due to impeded drainage, restricted aeration and unfavorable soil temperature. In this condition, nutrients will not be used efficiently. Optimum soil moisture regime is essential for efficient use of fertilizers by crops. The availability of nutrients is poor in coarse textured soil when compared to fine textured soils. The coarse textured soil needs more frequent application of fertilizers when compared to heavy textured soil. The higher the fertility of soil, the lower is the response to manures and fertilizers. When the organic matter of the soil is higher, the response to fertilizer by crops is more. Soil reaction is important for selection of right type of fertilizers. Rock phosphate is advantageous in acid soils. Crop factors. The response of crop to fertilizers varies with the nature of crop and variety of the crop. The fertilizer responsiveness of a plant depends on the cation exchange capacity, CEC, of the roots. The root CEC of dicotyledonous plants is much higher than that of monocotyledonous plants. Plants with higher CEC absorb more of divalent cations, Ca, Ng, whereas plants with low CEC absorb more of monovalent ions, K, Na. The ability of the crop to absorb nutrients from the soil depends upon the size of the root system, root length and spread, and characteristics like root surface and root hair density, etc. Large ramifying root system absorbs more nutrients. The association of mycorrhizal fungi with the roots of plants grown under conditions of low soil fertility increases the ability of plants to absorb nutrients such as P, K, Cu and Zn. Normally N, P and complete fertilizer application reduce the presence and activity of mycorrhiza. Agronomic factors. Fertilizer responsiveness of crops depends on timely sowing, proper spacing, proper dose, time and method of fertilizer application. Other factors. Climatic factors. Under drought and excess moisture condition, foliar spray can be recommended. In high rainfall area, split application of fertilizers and application of slow-release nitrogenous fertilizers are recommended. Yield goal. The economic yield or potential yield or targeted yield decides the quantity of manures and fertilizers application. For higher crop yield, optimum or maximum amount of fertilizers are to be applied. Cost of fertilizers. Not only the cost of fertilizers and manures, but also the cost of together produced decide the quantity of manures and fertilizer to be applied, that is, depend on the profit from the crop. It may be maximum profit or maximum rate of return per rupee invested. Availability of manures and fertilizers. Timely availability of manures and fertilizers, transport facility and labor for application decides the quantity. Nowadays, manures are not available to the required level due to various reasons. Slow-release fertilizers are developed to prevent the loss of nutrients by leaching and nitrification. It releases nutrients slowly and uniformly and increases the fertilizer use efficiency. Examples: neem-coated urea, sulfur-coated urea, lac-coated urea, tar-coated urea, N-Serve, isobutylene diurea, IBDU, Thieria, etc. Agronomic interventions for enhancing FUE. The following are the agronomic measures to improve the fertilizer use efficiency, FUE. Number 1. Using best fertilizer source. Number 2. Using adequate rate and diagnostic techniques. Number 3. Usage of balanced fertilization. Number 4. Integrated nutrient management. Number 5. Utilization of residual nutrients. Point 1. Using best fertilizer source. Identification of best source of fertilizer is prerequisite for better crop production. Source of fertilizer depends on crop and variety, climatic and soil condition, availability of fertilizer, etc. Nitrogen, ammoniacal or nitrate. Phosphorus, water-soluble or citrate-soluble. Potassium, muriate of potash. Sulfur, sulfate or elemental S. Multinutrient fertilizers, MAP, DAP, SSP, nitrophosphates. Multinutrient mixtures, several combinations of NPK. Fortified fertilizers, neem-coated urea, zinc-coated urea, boronated SSP, NPKs mix. Point 2. Using adequate rate and diagnostic techniques. The fertilizer recommendation must be in adequate quantity so as to meet the demand of crop at any point of growth. The fertilizer supply is made by diagnosing its requirement by any of the following method. State recommended generalized fertilizer dose or blanket recommendation. Soil test-based fertilizer recommendations. Soil test crop response-based recommendation. Plant analysis for diagnosing nutrient deficiencies. Chlorophyll meter and leaf color charts, etc. Point 3. Balanced fertilization. Balanced fertilization includes adequate supply of all essential nutrients, proper method of application, right time of application and nutrient interrelationships. A. Adequate supply of all essential nutrients due to more concentration and application on primary nutrients, NPK, soils developed deficiency symptoms for secondary and micronutrients. Hence, ignored elements must be added with the NPK, may be in minor quantity, to get higher yields in crops. Experimental results shown that about 20 to 25 kilograms of micronutrient application or to foliar sprays increases the yield of crops up to 20%. B. Proper method, N and K can be applied as broadcasting and band placement. Water-soluble P fertilizers are preferred to apply as band placement in neutral and alkaline soils. Citrate-soluble P fertilizers are applied as broadcast method in acidic soils. Sulfate forms of S fertilizers are applied as broadcasting or band placement, whereas elemental S and pyrite are applied as broadcasting method. Micronutrients are applied in minor quantity as foliar sprays and water-soluble fertilizers are applied in fertigation. C. Right time according to physiology of crop. Upland crops to splits, seeding 3 to 5 weeks after first dose. Flooded rice 3 splits, transplanting 3 and 6 weeks after first dose. D. Nutrient interrelationships. Antagonistic nature of fertilizers is to be considered while applying into the soil. Some of the fertilizer application in excess cause loss of yield and quality of crops. Example: application of excessive 120 kilograms PHA1 created an imbalance and reduced the seed and oil yields in soybean compared to 80 kilograms PHA1. Point 4. Integrated nutrient management. Organic manures, crop residues, green manures, biofertilizers, etc. are to be blended in right manner along with inorganic fertilizers to meet the crop demand. All the possible and available organic sources are to be utilized efficiently to reduce the usage of inorganic fertilizers. Point 5. Utilization of residual nutrients. Some of the strategies to utilize the crop residues in efficient manner are knowledge on climatic conditions and carryover effects of residues, blending rightly on cereal legume rotations, mixing shallow deep rooted crop rotations.
We politely request, please like, share and subscribe our channel Sri Raj Lakshmi Publication.